Welcome to Vantage Point Podcast, a podcast brought to you by NWR Communications and 92 Studio. This podcast is intended for education and entertainment purposes only and does not constitute financial advice.
John, welcome to the podcast. For those tuning in who might be new to what is somewhat a bit of a, I wouldn't call it a mysterious world, but it's not exactly mainstream additive manufacturing. Can you just paint a picture of what the current landscape actually looks like within the industry and particularly around the role or the importance of metal powders?
Sure. Yeah. So thank you. Additive manufacturing, or as it's maybe more commonly known, 3D printing, is making a part on a layer by layer basis, and so it's pretty intensive. It's thrown into the industry 4.0, all those kinds of fancy words, but at the end of the day, the 3D printer makes good metal or it doesn't make good metal, just like a cast part is. And then it goes downstream to get machined, anodized, coated, whatever. That's kind of the basis. The difference is that we're not carving it from a block to begin with. We're actually building it layer by layer, very similar to how you would do like Legos. So you're just stitching them together. You're just doing it maybe 45 microns at a time. So, think diameter of a hair, kind of dimensions. And so it offers this ability to make designs that would be really unaffordable or just impossible to make previously, and other savings that can come along. And so a lot of people are interested because it looks to be more sustainable. It's more efficient, uses less material, all of these goodness that comes from it. A lot of the processes, though, use metal powder as basically the ink in the 3D printing. And so that's kind of where we leaned into it. And, that's what we make. We make the ink for the 3D printers.
That's good, a good background. So you're obviously listed now on the ASX. There was a couple of weeks ago following the reverse merger of KTIG. You're listed on the ticker MPW. What was really the initial spark or problem? You talk about the ink required for the 3D printers, but what was the initial spark, for you and Chris to found Metal Powder Works so 7-8 years ago?
Yeah, well, it was a lot of I would say a lot of hard work went into it. I think the quote, "Experience is what you get when you're looking for something else." And back when Chris and I were both at Lockheed Martin Skunk Works, we were trying to figure out how to tap additive manufacturing to make small quantities of bespoke, hardware for these, small production runs that we did at Skunk Works. And the ability to avoid tooling, for example, and change designs flexibly is kind of a hallmark of the process. So fast forward that if that's what you really want to do, then you've got to, what we always say is you want a repeatable, reliable process, for any robust industry. And if your feedstock material is not repeatable and reliable, then how can your process be repeatable and reliable? Pretty simple concept, really. And fast forward a few years after I spent some time in Australia, came back to the US, and Chris and I hooked up again, and this time under the banner of Arconic. And we had a service bureau down in Texas, which is where Chris lives. And, we were facing this problem. We're trying to qualify hardware for Airbus using a 3D printer, and the inconsistency in the powder feedstock just made it very, very difficult for us to follow that fixed process. And so when we left, we finally said, well, there's got to be a better way. Surely there's a better way. So we both went to our spreadsheets. Interestingly, we kind of came up with similar math, working independently. Then we went down a path of figuring out how to physically do what was on the spreadsheet. And for me, being a materials engineer by background, the process economics are always really interesting. I'd studied this for years. So then we knew what had to be true. So really, can we get something that, if it's consistent, then then the economics should work out. Those two things tend to go hand in hand. So we have a very high yield process today with a very consistent product.
And when you talk about the product that you've developed, I think you refer to it as the direct powder process. Can you sort of explain in layman's terms how the process actually works to produce metal powders from premium bar stock, and what actually is premium bar stock?
Yes. So premium bar stock, basically what we're saying there is that it's bar stock is a ubiquitous form that metal comes in, similar to plate. Premium bar stock just means that it comes with a certification that says that it's good, and the chemistry is good, and the microstructure is good, and all that kind of stuff. So, if you're doing that part right, what we're requesting is something that's not elaborate or unusual or hard to find. It's just basically it comes with some pedigree, and you can buy it pretty easily. So what we do with that bar is rotate it at a couple thousand RPM. So we're rotating this bar, and then we contact the surface of the bar along its length with a linear tool that looks something like a comb. And at each point that contacts the bar generates a particle. So we do that. Think about tapping your fingers on the table, but if you did it at 10,000 times a second, you'd be close to the range that we're operating in. And so we can generate about 4 million particles a second today. So we have designs to double that and quadruple it. But today, that's how the process works. So basically, you've got these little teeth that are coming down, making contact with the rotating bar. That whole process dynamic comes together with a special algorithm that lets us do what we need to do to make that consistent particle.
Perfect. And just trying to get behind the sort of science and jargon of it all. You talk about non-thermal and operating at room temperature and why that's important. What does it actually mean? And again, what are the key advantages of approaching versus atomization and whatnot?
Coarse terms, if you think about atomization, is really just taking a metal to be liquid and dropping it into a gas stream where the gas is breaking up the liquid into tiny, tiny particles. And as it falls to Earth, it becomes solid as it cools. And that's basically, atomization in a nutshell. Now, obviously, it's a bit more elaborate than that, and there's a lot of science involved. But it's kind of the same as it's been for decades. And it even goes back to shot towers. That's how you made shot for shotguns, et cetera. So you'll see these shot towers littered through the countryside in different countries. So our process is one where we're more prescriptive. So out of that process, you get a wide size range and what we call powder size distribution. And in our process, it's very narrow. So we basically kind of do the opposite. We say, what size do you want? And we can go in and kind of make that. So it's more about computer controlled, it's math controlled, and it's mechanical in nature. And that's what gives us really that, very, very consistent particle that we make. You asked me about the room temperature process, and that's also really important because we're avoiding that melting, which has the opportunity to change the chemistry of the material that we started with. So by staying, under the melting temperature of the material at room temperature, we avoid really a lot of chemical changes to the material that transitions from a bar into a powder.
I suppose that comes back to your favorite saying of consistently consistent.
Yes, we like to be that.
Perfect. And just when I'm assuming with the process of direct powder versus atomization, the yield is much better. Can you just talk us through that?
Yeah, so that is the yield is really relative to what you end up wanting to do with the powder when you're finished with it. And so different industries want different sizes. And so additive manufacturing tends to want the smaller size fraction, say 20 to 63 microns. And that might be 30 to 40% of a yield out of an atomization run. So if it's a material like an Inconel 718 where there's a market for the other sizes, that's not a particular problem. Your overall yield is quite high, even if your yield for additive manufacturing is really small. Our process, because we have that narrow size range of production anyway, so we will be 95% efficient in that additive manufacturing size range. So it's much more prescriptive and a much higher yield, which is also what gives us good economics.
Beyond sort of yield, what else do you talk to in terms of key differentiators for the direct powder process, for the market in terms of quality characteristics, consistency, as you mentioned earlier?
Yeah, so very often with an atomized process, you'll wind up with small particles, which we call fines, and those can be difficult to work with because when they mix into the population, it's like mixing flour into raisins. It slows how that process, how the raisins want to move around. So our process doesn't generate fines, so we tend to have very consistent movement characteristics. And there's other artifacts that come into different forms of atomizing, ranging in sizes and shapes to what we call satellites, which is small particles. As they're falling to Earth, they kind of smack into the surface of a bigger particle. So it looks like you have this round object with another round object attached to it. And that has the ability to kind of work like Velcro. And so it also isn't good for the movement of the powder. And so we avoid all of that. We don't have those issues with the way we manufacture powder. That's why we call it the direct powder process, because it's pretty much you go direct from the bar to powder.
Maybe if we could step back just in terms of we're deep in obviously in the process side of it, but you're based in Pittsburgh. You obviously got a very American accent, with all due respect. Why list on the ASX? How did that all sort of come about?
Well, we merged with KTIG, which is obviously an Australian-based company. It's a technology that came out of the CSIRO as a weird twist of fate. I used to work for the CSIRO, so it kind of came full circle for me, 9,000 miles away. And so I think that part of the time from living in Melbourne for almost 5 years, really got to understand, I'll say, the Aussie culture around mining and minerals and metals. And it's a little bit different than here in the States. We tend to think more about part manufacture. Really very little thought goes into, like, how did it get here? And so, I can understand why companies like to list, that are involved in the kind of work that we are, why they like to list on the ASX, because it does seem to be a market that appreciates it and understands it, perhaps.
And just when we talk about, obviously the ASX, there's a number of peers, whether it's an IP or an X, Titomic or Ramiro, and then within the US, you've got, sort of 6K Incs, etc. Where do you sort of fit in amongst all of that?
I would say we're probably closest to Amero in that we both generate powder. We have a bit of a difference in that we use our own proprietary technology to manufacture the powder. A company like Hyperion X, if I understand it, is they kind of want to be from mine to part, running in a titanium space. So single material, whereas we have 17 different materials that we work with, and that grows every month, basically. And then Titomic, which I think we have a pretty good relationship with, also came out of the CSIRO and actually came out of my research program. Seems like a million years ago, but so know that process quite well. They would be a customer of Metal Powder Works. And so, we look forward to working with them as a feedstock to the cold spray process or the Titomic process, which would be similar to Speed 3D and others. So, Titomic, more of a hardware company. Amero, powder producer, also, does some part production. And then Hyperion X is kind of a combination of several things, but unique to titanium. At least that's how I understand that kind of situation.
And where does a 6K Inc fit in? For instance, they're one of the sort of market leaders, as I understand.
Yeah, so 6K Inc is interesting because they're not an atomizer like Amero is. They use their own technology like we do, and they basically convert a particle into a round particle. So they're remelting it, and so we've worked with them in the past. So they take our output and feed it into their process, and then you get a very high efficient powder coming out of it that's very, very round. And so for some processes, that's very desirable, but not for every process. So, the metals industry in general tends to be very collaborative. Mills work together because there's a lot of unique processes. And so even when I worked for RTI, Alcoa, or Arconic, we depended on our competitors to do some middle processing of powder. The end product was always different than our competitors, but we kind of needed that in-between space shared. And so we can work with a 6K, we can work with an Amero for their part production business, we can work with Titomic.
Quite a nice blend in terms of, instead of just competing, it's actually somewhat collaborative.
It is. I mean, I think that's the nature of the beast in a lot of ways. And it's probably easy to try to pit two things against each other, but Very rarely is it that simple.
And maybe just diving back into, obviously you're a powder company, maybe just talk to, the particular, powders that you talk to, whether it's copper, titanium, zirconium, et cetera, and just what's the sort of end use or end customer for those products?
So we offer today high strength aluminums. We offer coppers, copper-based materials like bronzes and zirconium, and then commercially pure titanium. And so our users are a mixture of people doing additive manufacturing, but also more traditional powder metallurgy. So it's important to note that additive manufacturing powder market is approaching $1 billion US. But the broader powder market is almost $6 billion. So there's a lot of people who are using powders for not additive manufacturing. And so we're very keen to get to know those people really well. The growth in that powder market is additive manufacturing. And so we very much want to have a concentration in both camps. And today we have a salesperson who's dedicated to additive manufacturing, and we'll be bringing on a salesperson who's dedicated to that traditional space. So it gets used in everything from making filters, metal filters, to printing parts that go to Mars. And so it's many and varied. We even have one company that we're working with. They're using aluminum powder to generate hydrogen from. Energetics is another big area. It's emerging quickly. We offer people an ability to make a powder that hasn't been made before. And so the situation where you can kind of craft a size and a shape to the downstream process can be very intriguing to people.
I suppose, obviously, you've got a unique product, and as you talked about, it's a product that hasn't sort of been to market before. You've been operating somewhat lean or clearly lean in terms of, from a cost base, privately. What does $10 million raised through the IPO do in terms of growth and being able to look towards next gen and the rest of it? How do you sort of look at that?
One thing we've not had was a sales team and a marketing budget. So I was the sales team and the marketing budget. So I'm really happy to have resources to go off. And so we've got that first sales professional we've already brought on board. We're looking to bring in a VP level person who's got experience commensurate with mine, many, many years in the engineered materials space and powder space. Having that kind of resource to allow me to go focus on other elements, growing the company, stabilizing the workforce, and getting our capacity up. And the other thing that we have done is over the year, we've really taken a look at where our cost tends to be. And we've come out with a new architecture that minimizes or eliminates a lot of that cost. So touch labor, for one, will be basically non-existent in our new architecture. So we have a goal to really get the cost out of our process, because that helps everybody, improves our margins, and it gives the customer a better result. And then the last thing is speed. And so every time I ask somebody, what we're doing and why we're doing it, I always ask them, could you do it faster? What would it? And I'm not being cheeky about it just to be mean or a jerk. I'm basically pushing to see what is it that it is the reason why we can't go faster. And if it's most of the time it's a people resource, well, that's fixable. We can go hire another engineer, and we've done that. So we've reinforced engineering, and we're going to look for another technical officer as well. So we're going to get that production capacity up, which allows us to earn more revenue. So it's a pretty simple mindset. We have some capacity inside the facility now. We need sales resources and marketing resources to go get those customers, and then we'll improve that further with more output.
Makes perfect sense. I want to get to the sort of onshoring and defense side, but before we do that, if you could just sort of talk to your existing customer base and what that sort of looks like and how that's grown over time as well, and where you think it'll go the next sort of 12, 24 months, or whether you've got enough customers now and it's just about expanding across different products.
Well, you can never have enough customers, but we're very cautious around that as well. Whatever we put on our plate, we have to be able to finish. And so our number one customer is our strategic partner in the titanium space, and so we're working with them very closely. And that is a non-additive part. Helps us in that traditional space, and their appetite for powder is quite large in production. So we're going through a testing program with them at present. We're about ready to ship that powder out this week. And then our other customers are kind of many and varied across defense, nuclear, I don't want to say automotive, but mostly defense type clients, but in aerospace too. So it's a very diverse space in terms of people that use powder, which is inherent in the two buckets that I pointed out. So you sort of have additive manufacturing, which tends to be more aerospace defense heavy, and then you've got the traditional powder market, which tends to be more industrial in nature.
And I've heard you talk to sort of the onshoring or ability to deliver powders to defense to then assemble essentially weapons in field. Can you just talk to us how that works practically and how that might look?
Well, I think one is, I'm quick to point out to people that, we would be the only dedicated domestic producer of copper, zirconium powders in the US or in North America today. This ability then to take the powder production in an expeditionary setting, as we refer to it, is then also relatively unique to us because of our small footprint. And so we have the ability to put our unit in a 10-foot ISO container, and that can very easily be put on a naval vessel and then offloaded. And so you can imagine our friends over at Speed 3D have an expeditionary unit that they've seen some acclaim for. It's looks like a big green monster integrated into a 20-foot ISO container. So you can imagine our 10-foot container with our powder producer sitting next to their 20-foot container consuming the powder that we generate. And now if you're an expeditionary unit in an armed forces, it's a supply chain, it's a logistics chain that you have one less worry about, because now you have the ability to make or repair a part wherever you happen to be.
In terms of being located, you talk about based in America. How important is Pittsburgh? I think it's Neighbourhood 91. How important is that? From a strategic perspective. It's close to defense, I'm assuming as well.
Yes, it certainly is. So in Pittsburgh's known for a lot of things. It's got a very strong history in materials. Most people know it for steel production. We have a football team called the Steelers, but it was also the first production aluminum was manufactured in Pittsburgh with Alcoa. And today it still has a pretty rich history in this region with strategic materials. There's a lot of material manufacturing that goes on around here. There's a lot of other manufacturing plus robotics, artificial intelligence, and automation that's coming out of the great universities nearby: Carnegie Mellon, University of Pittsburgh, Penn State. And so Pittsburgh's done quite well in that area. Pennsylvania produces 40% of North America's metal powders. So this region's particularly strong in that, which is the reason why Chris and I moved our development site in Austin, Texas, up to Pittsburgh, which is where I live, because of the workforce. And so we were able to tap into people that already know a lot about metal powders and how to safely handle them, which is critically important, while they learn about our new process of making the powders. So Pennsylvania, sits in the Northeast. There's a very strong defense industry in the Northeast, and then as we're kind of at that bridge of the Midwest, and so next door in Ohio, I guess, is technically where the Midwest begins, but we're quite close to that. So there's a very strong region in manufacturing, a very strong region in materials, powders, but also in defense manufacturing.
And you merged with KTIG. Obviously, they're also based in Pittsburgh, as I believe. Can you just talk to us? Obviously, it's a blend of two very similar companies or similar fields. Just talk to us how that you're starting to see the early signs of synergies, or what you might potentially be able to extract from each other.
Yeah, so we had our get together session last Friday. As a matter of fact, we had lunch and cake.
Metal Powderworks cake, to be specific.
Metal Powderworks cake, although no metal powders were used in the fabrication. So we had a great conversation about that team, what their skill sets are versus the Metal Powderworks team and its skill set, which is inherently more technical versus inherently more sales and applications focused. I'm quite keen to get them relocated from where they are into Neighbourhood 91. So Neighbourhood 91 is an advanced manufacturing campus. It's got a specific focus. It was started by the Pittsburgh International Airport. As such, we're on airport grounds. So if you come to visit, I can drive 5 minutes, pick you up at the airport, and you can be at Metal Powder Works, quite quickly. So from customer standpoint, people being able to come in, see what we do is much easier now than if you're located an hour away from the airport, which is a little bit where KTIG was. So we're looking forward to having them join us at Neighborhood 91 here imminently. And then we have a great showroom for people to come, if they're coming to see KTIG, they can go do that, or they can come see Metal Powder Works, or maybe they do both, because we actually we've learned that we share a few customers. So that's another interesting element. And the last thing I'll point out is the thing that's a little bit unique to both companies is the fact that we own or have exclusive license to the technologies that we're using. So, KTIG having been a patented CSIRO invention, but exclusively licensed gives KTIG, unique perspective on that space. And Metal Powder Works, of course, have our own technology that we're commercializing.
Since listing, I think it's probably a couple of weeks ago now, stock's up some 125%. It was obviously listed what many now see as an attractive valuation. Why do you think shareholders should be excited for the future in terms of what's planned? The industry growing, more applications, next gen, production unit. How do you look at that?
Yeah, well, I think we've talked about numerous pieces of the Metal Powder Works piece of that puzzle, which is, we have our own unique technology. It's highly efficient. We're brand new, and we're learning things every day. So we've learned, for example, our copper powders, when used in a laser-based 3D printer, it doesn't reflect all that laser light, which means that you can print at a lower power, which does all kinds of other good things for you. So, it allows us to say, well, people say, hey, your powder's not round. We can say, yeah, that's right. It's actually better in those regards. To the overall market, so I mentioned how the traditional metal powders market is $6 billion. It isn't really growing though. So it's a big market to go after. Additive manufacturing is growing at, depending upon which analyst you follow, in the neighborhood of 20% per year. And so it is quickly growing. So that's good news from a macro standpoint that, we're selling into a growing market. So there's a big market for one, and it's also growing. So we've got our own mousetrap, and we think it's better, faster, cheaper than the other guys.
And just again, stepping back from an employee base, how many employees would you have currently now across both Metal Powder Works and KTIG as one?
We'd be looking at a neighborhood of 10.
Yeah. Okay. So still a very small team.
Still a very small team. Yeah. So we get a lot of output.
Yeah.
For that small team.
And I think that's one thing that that investors have seen as attractive, that you've got an existing revenue base, obviously, but you're importantly not burning a whole heap of cash alongside that, without having to dig at peers, different processes, different companies, but they're burning as much more. How do you sort of see in terms of the $10 million actually being spent? Is it how much is this next gen going to cost, and how much? I'm assuming this cash should last you, all things being equal, a good couple of years plus.
Yeah, that's what we're planning on. So we've been conservative in the customer adoption process. Having lived in the defense world most of my adult life, I've been the guy who's coming up with that additional test that is needed so that we can, go down the path. It does take, 2 years or so in some cases to get there. Now, there are other cases that, maybe they don't have to be in a medical implant or on an airplane or on a rocket ship. So those applications do exist. We're working on those as well. So it's about a sense of balance, we're not excluding one, but we're not focused on all of one. And so when we use those funds, as we've said, sales and marketing is one area of use. We're going to do next gen. That's not a very expensive proposition because we've done a lot of homework over the last year to determine what it would look like. We expect to implement that in the first quarter of next year. So, and the other pieces too, like as we were just talking about, the efficiency of the labor. So our process is very efficient. So one technician can run 4 machines. And honestly, we've run overnight before. So we don't need a human to be there necessarily. It's a very automated process. The same can't be said for atomization. It does require a team of people, some pretty dedicated resources and specialized skills to run it.
You've been listed all of sort of 2 weeks. Has been feels like somewhat of an overnight success in 7 years. How's the experience been on the ASX? Obviously, it's handy to be talking when the stock's up quite strongly, but yeah, how do you sort of look back at the last sort of 6-month process?
Yeah, it's a lot. It was methodical. We answered a lot of questions. We had to go through a lot of accounting exercises as a small business. Coming up to an international standards was a fair amount of work. I'm not going to lie. Listing the day that the Dow dropped 900 points was a bit of a gut check, but we wound up positive of the day. So at this point, knock on wood, it seems like the market believes in our story. Now we need to execute.
I'm assuming, I'll finish up here, but I'm assuming those in the market should believe the story in terms of the history. And probably one final one that I just wanted to touch on was, yeah, you've had so much experience in the space. You've obviously got the Barnes Global Advisor side, in terms of your background. How important is it from a reputation standpoint in an industry that isn't, it's not exactly B2C or new products, new shiny software, etc. How important is it to have a really strong reputation, actually know what you're talking about?
Well, I think it's huge. I mean, it's not something that you can go. You have to earn it, for one, and you have to earn it every day. So, for our shareholders, what it means is that, if we come up with an idea, there's a good chance we can go find somebody to go help us, do that first pilot or that first test and validate what we're thinking with some pretty high caliber people out there in universities. So whether it's, Carnegie Mellon or Purdue University or RMIT, we're pretty well connected across that scheme to get answers to some questions, maybe more fundamental questions. You're always going to have those fundamental questions that you need to go, get an answer to. Without that network, they just go unanswered, and that's probably not a great way to exist. So, Chris and I have worked very hard. I was talking to some investors this week, as a matter of fact, and they were leaning on the defense piece of it. And I said, look, I've been in defense 20 years. It takes X time to be able to get through. We understand that. Chris and I have both worked in that space.
Not your first rodeo.
Not our first rodeo, no. And Chris comes in with oil and gas experience as well. So we, as I always like to joke with my kids, I know a lot about a very few things. No, but we actually do know the processes. The processes are really important because the exact materials and the exact parts that you're making, a little bit less important. If you get the processes right, you can get the qualification right.
You've done an amazing job so far, John. Well done for everything that you built and the successful start to listing. It's only obviously just the start, but thanks so much for joining us. We look forward to following the story. Thanks again.
Yeah, thank you, Simon.
Cheers.